Chapter.
An experiment.
We don't know yet.
Why is light so fast?
Like, it sounds so simple.
They had no idea.
But now the data speaks.
I find this not only refreshing, but at some level astounding.
Nature.
Welcome back to the Nature Podcast. This week, a study assesses who's responsible for heat waves.
And the scientists fighting back against US funding cuts. I'm Shamini Bundell.
And I'm Benjamin Thompson. First up this week, a study in Nature has attempted to identify who is responsible for the intensity and frequency of heat waves. Reporter Nick Petrichow spoke to Nature's climate reporter Jeff Tollefson about the story. Here's Nick.
So there's this new study in Nature that is essentially looking at how to attribute responsibility for heat waves. Can you lay out for me, Jeff, what exactly they were doing here?
So for a long time, more than 2 decades really, climate scientists have been kind of developing the research that would allow them to kind of allocate the responsibility for a lot of extreme weather events to climate change itself and say, climate change contributed X to this storm or to this drought or to this heat wave. This study goes one step further and says we can actually draw a causal link between the emissions that come from the fossil fuels produced by various big energy companies and state-owned companies that they call the energy majors, and they say we can draw a causal link between those emissions and any given heat wave.
And, in this paper, they refer to them as carbon majors, but these are people like Exxon, BP, Gazprom, that sort of thing?
Yeah, they've got all of the big oil and gas companies that you might think of, but they've also kind of broken out other state-owned entities. So you've got Saudi Aramco, which is a Saudi Arabian oil producer. You've also got kind of a generic coal from China and from India. So there are multiple categories of kind of entities, but together they all kind of make up these carbon majors that are basically the world's leading fossil fuel producers.
And so they've looked at these fossil fuel producers and then they've looked at heat waves to try and link the two. What exactly did they find by doing this?
Well, it's a multiple step procedure. First they looked at the contribution of climate change to some 213 heat waves from 2000 to 2023. These are kind of the big recorded heat waves. And they kind of allocated blame to climate change first. And then the second step was to divide up that blame among the various carbon majors, which together account for something like 57% of global emissions. So in the end, if you look at the blame, you see that collectively these companies all contributed to increased intensity of the heat waves and to increased probability of the heat waves. And then the last step was to look at the individual companies. And so, for example, you could take a company like ExxonMobil. They are able to say, ExxonMobil contributed this number of degrees to this heat wave, which happened in 2021 in the Pacific Northwest. And they made it more than 10,000 times more likely, so that's the kind of their median estimate.
I guess the science is pretty robust on linking climate change to things like heat waves, but how did they manage to link it to specific entities?
Well, there are some fancy statistics here. And, in some ways, the simplest way to think about it is they're using established science to link a given heat wave to greenhouse gas emissions and human-induced global warming. And then from there, you can kind of just divide out the responsibility. So these companies are responsible for 57% of global emissions. So that allows you to kind of parse out the collective impact. And then you go down through the list and you just look at the percentage of emissions and allocate the impacts by company. It's more complex than that, but that's the basic idea.
And what size of impacts are we talking about here?
Well, they're pretty substantial. On average, if you look at the cumulative impact of the emissions from these carbon majors on heat waves, you get something like a 1.7 degree increase in the intensity of heat waves from 2010 to 2019 over the course of that decade. So, that's a substantial increase just in terms of the intensity of these heat waves. And then on the probability side, you've got even, more eye-popping numbers. Like I said, a lot of these companies, you can take their emissions and you can basically say that any given company enabled one of these heat waves. What they found on that front is that, nearly a quarter of the heat waves can be attributed to the individual emissions of a single company. So what that means is basically any one of these companies enabled many of these heat waves to occur. That's the median estimate. There are a lot of uncertainties, and if you go with the 95% certainty bar, and then you look at the lower bound, in many cases, those numbers will be much smaller. In the case of the 2021 heat wave, for instance, they estimated that the minimum bound for ExxonMobil is that they contributed to a 19% increase in the probability of that heat wave. And overall, there was a 7-fold increase in the probability of that heat wave. But that's considered kind of a minimum bar. On average, if you look at the median estimate, we're talking about, numbers that are in excess of 10,000 times more likely for any given company for, many of these heat waves.
And so what does this mean for, I guess, everyone on the planet who's being affected by heat waves? I know one thing we've seen in recent years is legal action about climate change and how climate change is affecting people. Is this something that could be used in such cases?
Absolutely. It can be, and I'm certain that it will be. This will be part of a larger body of evidence that will factor into various lawsuits that are aiming to hold fossil fuel producers accountable for the emissions from the products that they sell. So there's kind of little doubt about that. The legal experts that I spoke to also say that, science is just one factor. There are a lot of questions that come up. Should you hold fossil fuel producers accountable at all for the products that they sell when they are abiding by national laws and often subsidized by national governments? So it's a legitimate question, and it depends on how you think about it. A lot of these lawsuits are basically following the pattern that was set by the lawsuits against tobacco companies. So they are basically alleging that one reason you can hold fossil fuel producers accountable is because they knew of this problem before the general public, and they tried to block climate policies that would have prevented fossil fuel emissions. And in some cases, they tried to undermine the actual climate science. So this is an argument that's out there. We'll have to see how that plays out in courts, but that is one way that this could play out. One other thing to think about is that this framework can also be applied to many other questions. You could just as easily, apply this framework to individual nations and figure out how much any given nation contributed to a given heat wave, or any given industry, whether it's the automobile industry or the power industry. And of course, then there are other types of climate impacts that are not covered here.
And I guess a question I have as well is, can we really tie the blame to these companies, these carbon majors specifically? Because I guess they're producing these fossil fuels, but all of us are using them in our cars for heating our homes, etc. So, there is an element of blame to all of us, I guess.
Oh, absolutely. And, that's one reason why you can use this same framework to divvy up the pie in different ways. The answer that you get depends on the question that you ask. So this is a framework that you can use to kind of attribute blame in various ways. Like I said, you could look at nations, you could look at industries. In the case of this industry, it is a particular situation where there are a lot of allegations that the fossil fuel industries actively tried to block action on climate change and undermine science. That's the logic that's being raised in some of these lawsuits and has been raised by some of the people that we spoke to.
And so what do you think will happen now?
Well, it's hard to say. The climate lawsuits have been going on for a long time, and as yet, I don't know if they've had a lot of specific influences on national policies. But, they are moving along. There have been rulings. This could contribute to more specific rulings for damages. But I think, the main thing for us, perhaps, is that the science is going to continue to evolve. What we're learning is that questions that we didn't think that we could answer 2 decades ago, we now can answer. There was a time when climate scientists would say, well, I can't tell you what caused this specific storm, but I can tell you that it's consistent with theory that you would have more such storms, more powerful storms. Well, now, 20 years later, we're actually beginning to allocate blame for specific climate events and for specific damages. And I would imagine that that is only going to continue as the science improves.
Jeff, thank you so much for joining me.
Thank you.
Jeff Tollefson there, talking with Nick. To read Jeff's story, look out for a link in the show notes.
Coming up in the show, the ways that US researchers are taking on the Trump administration. Right now, it's time for the research highlights with Dan Fox.
Shifting tides along the coast of ancient Mesopotamia might have spurred the rise of the world's oldest civilization. Urban settlements first appeared on the Mesopotamian plain more than 5,000 years ago. Now, archaeologists may understand how large-scale irrigation could have helped this complex society to develop. Researchers studied a sediment core drilled at the site of the ancient city of Lagash, now in modern-day Iraq. This helped them to compile a history of how the Tigris and Euphrates rivers meandered across the plain and deposited sediment. Changes in the sediment buildup could have altered tidal patterns along the coast, in turn affecting how much water was available through the year for farming. The team suggest that people joined together to build tidal and then river irrigation systems, and that these collaborations gave rise to urbanized clusters. Read that research in full in PLOS ONE. Researchers have devised a way to electronically switch the strength of a pair of glasses, a development that could catch the eye of bifocal wearers. Scientists used liquid crystals to produce lenses which can zoom in or out in response to an electric field generated by battery-powered electronics in the frames. With a gentle touch to the right temple or arm of the glasses, users can retune their vision to focus on objects near or far. The authors say the new technology has potential for mass production and might be especially useful for virtual reality headsets. Take a closer look at that research in Physical Review Applied.
This week, Nature has a feature article looking at how scientists are pushing back against efforts to reshape, or in some cases constrain, the research enterprise in the US, which has been initiated by President Donald Trump. Two of the feature's authors are Nature's Heidi Ledford and Max Kozlov, who join me now. Heidi and Max, thank you so much for being here.
Thanks for having me.
Thanks for having me, Ben.
So before we get to the responses, then, why don't you give us a sense of what these scientists are responding to?
I would say since the beginning of the Trump administration, there's been a lot of uncertainty about what the future of science is in the United States. It's been a pretty difficult time for quite a few scientists, whether they've been directly affected by their grants being canceled or losing their jobs if they work for federal agencies. And a lot of concern that the public just isn't aware of what's been happening, how important science is first, and second of all, the threats to it that researchers are facing now.
I think there's been kind of a systematic, a whole-scale dismantling of the U.S. scientific enterprise that has led to so much uncertainty and things broken left and right. And so I think academics all over the country are rethinking what their place is in the research community, in the scientific community, with all of this in mind. Many, we've reported, are considering leaving the country. And so I think everybody's thinking about how they can continue their research given the difficult situation for universities.
And yes, you've been speaking to a bunch of these different folk then about efforts they're engaging with to try and undo or rescind these decisions. We're going to talk about a few of them today. And in the first one, you spoke with Nikki Maphis. Now, in your story, you talk about how she had a grant application essentially binned with no warning at all. Now, we've got a little bit of audio from your interview with her. It's a slightly wobbly phone line, but she's talking about why grant and training funds for early career researchers are so important. Here she is.
It impacts your career trajectory. It sets you up for success. It kind of lays out this flight plan in order to set you up your own lab. And for me and the hundreds, maybe thousands of researchers across this country that are in the stage that I'm in, like later stage postdocs trying to launch an independent research career. We have just been completely stymied and stopped, and there's nothing we can do about it except for what I'm currently doing about it, which happens to be this lawsuit.
Yeah, so she, as she describes, is taking part in a legal action then, because the courtroom is where a lot of these responses are taking place.
Yeah, so she is one of a handful of researchers and organizations representing researchers that sued the Trump administration for essentially binning applications, for terminating grants on a whole slew of topics from DEI to COVID-19 to climate change. These are projects that they're, in some cases, years into and have already spent thousands or even in some cases millions of dollars. And so Nikki is in a really precarious situation because she is coming to the end of her postdoc, and like so many others, she has to make the difficult step of starting her own lab. And there are specific grants that the NIH, the National Institutes of Health, puts out to help researchers with that transition. And she, being a woman and from a low-income family, she applied for one that's geared toward underrepresented minorities in science. And then all of a sudden, her funding opportunity disappeared. And a staff member at NIH said, "I'm so sorry, but your application has been pulled." And she told me that she'd never cried more as a scientist than in the last 6 months.
And this is then where the lawsuit comes in.
Yeah, so Maphis and a whole slew of other researchers have joined this lawsuit and others, alleging that the Trump administration has essentially terminated these grants without any kind of cause, and that the policies put in place are totally arbitrary. You know, for example, their whole crusade against any kind of DEI research. I mean, there's no definition of what DEI research even is. And so that means that they have been able to cut essentially whatever they want to that fits under that umbrella, the researchers allege in the lawsuit. And it came to a head in June when a federal judge who was appointed by a Republican and who's been on the bench for more than 40 years, he not only ruled in the researchers' favor, but he said, "This is the worst racial discrimination I've seen in my 40 years on the bench." And the researchers, they didn't even raise any kind of racial discrimination portion in their lawsuit, but it's clear that in targeting quote unquote DEI research, in targeting research that benefits LGBTQ folks in the country, that is what the Trump administration has done. And so I think a lot of researchers were really encouraged to hear a judge, and a judge appointed by a Republican, say it so clearly.
I'm sure, though, the Trump administration doesn't think this. What have they said?
Yeah, basically the Trump administration has doubled down on its stance and has said that it stands by its decision to end funding for research that, quote unquote, prioritized ideological agendas.
And so in some cases, then, Max, grants have been reinstated. Not all of them, it must be said. Is this the only attempt like this to go through the courts?
No, there's a whole slew of efforts. There's a group of University of California researchers that have also sued to get their grants back, specifically in the University of California system. And I think what's special there is it's really just the researchers who are leading that effort. I will say some of these cases have yielded some success. However, I think the bottom line here is even if the grants are reinstated, the damage has already been done in that their funding was put on hold for several months. And in some cases, even if their grants are reinstated, they still don't have access to their money. So it's to say that these efforts are important and they give these researchers absolutely an important sense of purpose. But even if a judgment is ruled in their favor, it could still get tied up in appeals, as the case with Maphis has. It has gone all the way up to the Supreme Court. And even if the grant funds are reinstated, it's a long journey to still restart that research. It's not as easy as just turning the lights back on again.
Well, let's hear once more from Nikki Maphis then, and the outcomes she'd like to see.
I just want this to stop. I just want it to go back to how it was because it was working. We were doing research that mattered. Research touches every aspect of the community, and it's incredibly important within each community in which these universities are located, from the biggest cities to the smallest towns. They're economic drivers. They provide jobs. And it's been really exciting because I've been able to see how the first phase was so hopeful and exciting and successful. And I've known people who they got their grants back. And if being in this lawsuit means that happens, great.
And you can absolutely hear the passion in her voice then, say, putting herself up as she has. But there are other efforts going on too as well. One thing researchers, as we know, are very, very good at is gathering data. But maybe one of the things that being done here isn't gathering, but rescuing, perhaps, is an apt phrase, data as well. We spoke about efforts on this a while back, Max, and how this was kind of something that researchers were looking to do, but really they have picked up the ball and run with it.
Oh, they've done that and more. You know, it started as really a Google spreadsheet of a list of all the grants that have been terminated by agencies like the National Institutes of Health and the National Science Foundation. And then since then, they've launched an entire website. They've made their data easily searchable. It's gone so far as the judge in Nicole Mathes's case, he cited them as basically a physician's desk reference of grant terminations. And their role is just so important because the health department has put out its own list of terminated grants, but this is coming directly from the government, and journalists and scientists were immediately skeptical of this list. And so what their work does is really verify that that list is accurate and then fill in the gaps. And it makes it much more searchable and workable to find trends in the data. We did our own investigation at Nature a few months ago, and we found that essentially more than half of all the research done about LGBTQ plus folks has been terminated in just the span of 2 months. And so it allows journalists, scientists to do this kind of important work that would otherwise be missing because we just wouldn't have the data for it.
And of course, there's another side to this as well. It's not necessarily all through courtrooms and the internet that this is being done. Heidi, you've been looking at, dare I say, a more grassroots approach as part of efforts to try and help maybe shift perceptions of scientists and science in general in the face of growing apathy and worse.
Yeah, that's right. So I spoke to 3 organizations really that are mainly, I'd say, trying to remind the public or even just introduce the public to what scientists do and why it's important. There was one common thread among all 3 of the groups that I spoke to, which was that over the past few years, especially since COVID, all 3 of them had noticed the discussions online or when they go back to their hometowns, especially if they're from rural areas, that they would hear strange things, these suggestions that scientists, when they get a grant, that all that money goes into their pocket somehow, which is obviously not true. Or they would hear the kind of misinformation that sprung up around COVID vaccines and is potentially being spread to encompass other vaccines as well. So 2 of the groups have been on letter writing campaigns to hometown newspapers in particular. One of them is called Science Homecoming. Another one was called the McClintock Letters. And both of them are trying to get scientists to write letters to the editor, basically, or opinion pieces. Scientists tend to cluster around more urban areas. Many of them come from the more rural areas, though, within the U.S., and they don't necessarily go back home and talk about what they do that often. So it's nice, I think, to have a way to reach out to more remote populations that don't hear that much necessarily about what scientists do.
So local papers, then. This is not just letters to the New York Times, for example.
That's right.
And what sort of things are these letters saying, or what message are they trying to get across?
So some of them write about their own personal journey from, maybe growing up on a farm in rural Kansas to studying plant pathology because they were inspired by their background as a child. Others will write particularly about medical research, I think, and the importance of what they're studying for developing new therapies for disease. Another approach also is to just point out the economic benefit of funding for science and how for every dollar that the NIH invests in scientific research, that this then gets magnified in terms of economic impact for the area in which that money was invested. So just to try to bring home, I guess, both the importance of the work that they're doing, I guess also to some extent the character of the people who are doing it in a way, because there is this perception that's being spread online. You could hear it a lot, for example, in a hearing before Congress when the U.S. Health Secretary talked about how scientists are in the pocket of pharma, and the folks who were organizing these campaigns wanted to do something to counteract that.
And what sort of a response have they got? What have folk told you about this endeavour?
So they have managed to publish quite a few letters, in the hundreds at this point, and some of them did get some feedback and some positive feedback. Now, I did also, though, speak to a social scientist about the sort of effectiveness of this kind of approach. And she did say that the idea of targeting a hometown newspaper is quite appealing because that is something that academics might not immediately think of right away, but it is a good way to go to where the people are, meet them where they are, rather than expecting them to log into the New York Times or the BBC. But she also said there's a limit to what you can do by just asking people to listen to you all the time, and that sometimes you need to show, right? Like we always have this saying in journalism, you need to show, not tell. And she said what universities really need to work on is making themselves a more integrated and important and valued member of their local communities, and that maybe has fallen by the wayside a bit, and that might take a longer term investment. But that ultimately is maybe what they're going to need to do in order to counteract this narrative that's been emerging of them as elitists or out of touch. But the other thing is I don't want to dismiss the importance of these kinds of activities either. I mean, it's sort of like when people gather together to have a protest. That may not necessarily change that many minds, people who are skeptical of whether or not, this scientific funding was a useful exercise of taxpayer money may not be convinced when you have a big rally and carry lots of amusing signs. But it does help to bring people together into a community so that they can then engage in additional activities going forward. Similarly, with these letters, they're not the end game, but they are potentially a useful step along the way.
And how are these researchers feeling about their chances of success, what they would consider success, I suppose, reintroducing grants or undoing cuts, this sort of thing?
I think it's harder maybe to measure success from an indirect action like this. And it is maybe a piece in a longer term strategy. And some of these organizations are planning to move on to other kinds of activities in the future. But I do think one thing that was really tough in the beginning was so many scientists just felt like nobody knew or cared, in part because there's so much noise in general, so many changes happening all at once that this just becomes one story among 20 that come out in a day, right? But also because they sort of realize, I don't know that the public necessarily knows what I do. And therefore, who's going to champion for this? And so I do think it is an important step to try to make sure the public does understand what scientists do and why science is important, but also, honestly, for some of those scientists to feel heard and to feel seen as well.
Heidi Ledford there. You also heard from Max Kozlov. To read their feature, look out for a link in the show notes.
And finally on the show, it is time for the briefing chat, where we discuss a couple of stories that have been featured in the Nature Briefing, which is Nature's daily email roundup of the latest science news. So I'm going to plunge in with my story first, and it's a really interesting article that I was reading in Nature from a paper in the New England Journal of Medicine, and it's all about various attempts and some new success with treating type 1 diabetes with genetically modified cells.
Okay, so type 1 diabetes, then an autoimmune lifelong condition relating, of course, to the pancreas.
Yep, and it's the pancreas cells that stop functioning in type 1 diabetes, and that is what this paper and a lot of sort of recent research are focusing on. And it is about trying to get new cells into the body, essentially, that do work, that will produce the insulin that the body needs to control the blood sugar, which is, of course, a problem. If you have type 1 diabetes, you might be needing to take replacement insulin from injections or an insulin pump in order to manage blood sugar levels. So the ideal that various companies and researchers are looking for is a way to avoid having to do all this monitoring and have this dependence on sort of external insulin, potentially. You want to be able to have a treatment that allows their own bodies to continually produce insulin, as the pancreas normally would. And this is a really interesting breakthrough where they have implanted pancreatic cells from a deceased organ donor. But the key thing, and this is what they were really going for here, is that they've genetically modified the cells so that they don't trigger the recipient's immune system. So they sort of evade detection, which means that the person who has received these wouldn't need to take immunosuppressant drugs.
Right, which is, of course, a big problem with transplants. If you're looking to use, say, animal organs, which is something that I think has been looked at as well, that is another problem there, right? The immune system gets turned on and will attack the implant. But in this case, that's trying to do away with all that.
Yeah, because immunosuppressant drugs, there's risk of infection, there's risk of cancer, there's all these sort of side effects. And a lot of the ways that people have been looking at it so far do require some sort of immunosuppressing in order to work. For example, there's been work going on with getting stem cells to then turn into pancreatic cells in the body. And there was some recent results that sort of showed quite a lot of promise in that in treating type 1 diabetes, but there's still a sort of immune issue there. Another one is using the person's own fat tissue to make, again, stem cells, which can then be reprogrammed into these pancreatic cells. That seemed to go quite well as well, but you have to take these anti-rejection drugs.
So this approach then is looking to avoid some of those issues. And how have they gone about doing it specifically?
Well, we've got some CRISPR gene editing, and there's really specific genes that they've gone in to try and tweak, seemingly successfully. So there are some genes that usually would be flagging foreign invaders to the T cells in the immune system. And then there's a protein called CD47, which is really important to stop the immune cells attacking the wrong thing. And they've used a virus to sort of shuttle genetic instructions for that protein into the cells. And with all of these changes together, any cells that have all of these gene edits, that seems to, in their small test, allow these cells to survive without any immune interference for, they say, 6 months.
Seems like early days, Shamini. What sort of stage are the researchers at with testing this new approach?
Yeah, super early days at the moment, because what they've done is they've basically got one patient, a man with type 1 diabetes, and they've injected a very low dose of their genetically engineered cells into him. So that's 80 million cells is apparently what's referred to here as a deliberately low safety test dose. And looking at it 12 weeks later and then again 6 months later, they have found the genetically engineered cells are able to produce insulin and are not getting immediately wiped out by the immune system. So it's not yet at the stage where, obviously what we're going for would be you want someone with type 1 diabetes to be able to, have a treatment that will last forever. So they haven't done that yet. And there are people who are quoted in this article as well who are maybe a little bit skeptical at the moment because there's been a lot of other work trying to do this kind of thing that hasn't worked. So they kind of want to see a bit more confirmation of how successful it is. But potentially this kind of immune cloaking, because they're sort of trying to hide the cells from the immune system, if you could combine this with the work I mentioned about taking stem cells and having them turn into pancreatic cells, some sort of combination of all these could potentially be even a cure for type 1 diabetes, which would be obviously amazing.
Well, fingers crossed then that these approaches bear fruit, because as you say, that would make a lot of difference for a lot of people. But in the meantime, let's move on to a story that I've been reading in Nature based on a Journal of Neuroscience paper, and it's about colour perception in the brain.
Oh, I feel like when I was sort of studying like second year psychology, there's all sorts of fun experiments you can do about what we're seeing and optical illusions and why we're seeing it. And colour, is colour real? All sorts of sort of philosophical mind-bending things.
Well, you're absolutely right. And these are things that have, puzzled philosophers and neuroscientists forever. Are we seeing the same colour? I mean, looking about my desk here, I've got a powder blue coffee cup, a yellow coffee cup, and a pink, I would say, maybe cerise coffee can, which I've got pens in. Maybe too much coffee-related paraphernalia, I have to say. But of course, the question is, if you sat here at my desk, would you see the same colours in these objects?
Yeah, because I might say, oh yes, this is definitely light pink because we've agreed. But is my sensory perception, is it the same experience in my brain as it is in your brain?
Well, quite. And we'll come on to that in a little bit. But I think what this research has done is maybe just opened that door a little bit into figuring this sort of stuff out. And it's a study looking at patterns of brain activity and exploring how different colours are represented in parts of the brain associated with vision. And the researchers behind this work, they used functional magnetic resonance imaging to compare brain activity in people who were looking at different colours. And they used these results to see which parts of the brain were firing. And after that, trained a computer using machine learning to look at these patterns and then subsequently predict what colours were being viewed by a second group of people on the basis of their brain activity.
So it's a mind-reading computer that can tell you exactly what colour you're looking at.
I guess kind of. I mean, it doesn't work every single time, Shamini. In most cases, the researchers were able to predict what colour was being viewed by the second group. But they also found that different colours were processed in subtly different areas in the same region of the visual cortex, and that different brain cells responded strongly to particular colours. And this was consistent across participants, suggesting that there are commonalities in the way the brains encode colour.
Which it sort of partly answers our initial question. It suggests that, if I may massively oversimplify the way the brain works, if there is a red area in my brain, it probably matches up with the red area in your brain. And if we're both looking at red, that's the bit that will light up.
But it doesn't speak to the subjective situation that we might find. Are we seeing the same red? And in fact, the researchers themselves even say that. They're quoted as saying, we can't say that one person's red looks the same as another person's red. So we have this idea that the brains are doing one thing, but of course this is a small study. It's only looking at a few colours. There's a lot more of the brain to understand. But as I say, it kind of gives this kind of neat insight into the way that we perceive the world.
So we still don't know the exact colour of all your coffee paraphernalia adorning your desk. But I think we're progressing. And listeners, if you want to read about all that for yourself, we'll put some links to the articles there. And if you want your very own list of stories in your email every weekday, we're going to put a link to where you can sign up to the Nature Briefing.
And that's all for this week. But if you'd like to stay in touch with us, you can. We're at Nature Podcast on X and Blue Sky, or you can email podcast@nature.com. I'm Benjamin Thompson.
And I'm Shamini Bundell. Thanks for listening.